Hi Ian, hi Matt, hi Somek. Welcoming you once again. I'm really excited for this webinar today and would love to welcome everyone who has joined us here for the webinar. We have an exciting plan for all of you. We really want to showcase kind of future of ML development. And yeah, we just want to make sure that this webinar is going to be really educative for all of you. Um, I think let's wait for a few more seconds for folks to join in, and then yeah, we can get started.
Sounds good.
Yeah. Meanwhile, all of whom who are here would love to know what your favorite ML framework is. I'm just joking. It should be Keras, right? Or where? And yeah, like just drop in the chat. Where are you joining from? At least in India, it's 10:30 p.m. It's quite late. But yeah, I would love to know where are folks joining from and your favorite ML framework. Uh, right. We can get going. I guess it's 10:32 already. For the housekeeping, you can use the chat, um, like ask questions to the speakers. Just keep the questions flowing. We will have Ian speaking first, followed by. We have some reserved time at the end for Q&A. We will try to have like 10 to 15 minutes of Q&A. So we'll try to cover as much questions as possible. But yeah, keep the questions flowing. If there's something exciting, we will love to like maybe break the flow and ask them question. But yeah, it's my pleasure to welcome both you, Ian and Matt, for this webinar, and thank you for uh, doing this with us. And now the stage is yours. Feel free to let the folks know what the agenda for the session is, and we are really excited for this. Over to you, Ian.
Great. Thank you so much. Well, Matt and I will just introduce ourselves real quick. My name's Ian. I work on KerasCV, and I've been working on the Keras team for a couple of years now.
Yeah, and I'm Matt, also working on the Keras team for a couple of years, and all on the natural language processing side in KerasNLP.
Awesome. Yeah, so before we get started, I just want to say a big thanks on behalf of myself and Matt to the Weights and Biases team. We're really excited to have this opportunity to talk with you all today and show off some of what we've been doing with Keras and Keras Core. So before we hop into it, I'll give you a sort of quick sense of what our agenda is going to look like. I'm going to give you a quick intro on what Keras Core is if you're not familiar with it. And then we're going to give you a little bit of background on what KerasCV and KerasNLP are, which we call our Keras domain packages. I'm going to show a hello world example of using KerasCV with Keras Core. And then I'm going to dive into a little bit of a technical talk about how you can use a pre-trained component from a framework of your choice and plug it into Keras Core. So for that example, in particular, we're going to be talking about torch vision. So to just sort of hop right into it here, what is Keras Core? So Keras Core is everything that you know and love about Keras. It is a new implementation of the same Keras API, and it is a full rewrite of Keras. It will become Keras 3.0 in the fall, and it is greatly reduced in size as part of this rewrite because we were able to get rid of a lot of tech debt related to TF1, which Keras used to be closely married to. The big exciting feature about this new rewrite is that we are no longer tied to specifically the TensorFlow backend. So Keras Core now supports all four of the backends listed here, which means that anytime you write code in Keras Core using the same Keras API that you're used to, that code will run in TensorFlow, JAX, PyTorch, or NumPy, with an important caveat that NumPy does not have autograd, so the NumPy backend can only be used for inference, not for training. And because the API is exactly identical, Keras Core is a completely drop-in replacement for TF Keras when you're using the TensorFlow backend in Keras Core. So any code that you've written in TF Keras, or what we call Keras today, will automatically run the same way in Keras Core as long as you're using the TensorFlow backend. You can read a little bit more about Keras Core and some of the development behind it at this announcement that I've linked below, and we'll share these slides with you all at the end of our presentation. But it's on Keras.io, and you can see a little more of the details about some of the theory behind it, why we've done it, and some of the things we're excited about with Keras Core. So to give you a little example of what this means and what this looks like to run things in different backends, here's just a little bit of code written in the Keras API. And you can see here that we've imported Keras Core as Keras, and that's just the same way as you would today import Keras from TensorFlow. And we can create all of the constructs that we're used to in Keras, like a sequential model composed of Keras layers. We can compile that model with Keras losses, Keras metrics, and a Keras optimizer, and we can use the fit, evaluate, and predict API that we're used to. But now, when we write this code this way, with simply a configuration change, we can run this exact same code across all 3 backends, and the numerics and functionality are exactly the same across all 3 backends. And there's a lot of really cool features of Keras Core that you can check out in the announcement, things like loading weights from one backend and saving them into another backend. All those sort of things work beautifully, and the interop is quite impressive. But we're going to dive into a couple of more specific features in this talk. Before we get into the depths of Keras Core, I want to talk about what Keras domain packages are. So there are 2 Keras domain packages, KerasCV and KerasNLP. And when we say domain packages, what we mean is that these are specific to a particular field of ML. So CV is computer vision and NLP is natural language processing. And these packages are simply extensions of the Keras API. So they're not a new sort of framework that you need to learn. They're not a new set of APIs or a different sort of paradigm. And in fact, it is just the same as the existing Keras API in how all of the components work. It's just that the components are very specifically tuned for vision and language processing. And one of the things that's newer about the domain packages compared to Keras itself is that we include pre-configured as well as pre-trained model presets. So in a single line of code, you can actually load up a pre-trained, for example, BERT model or YOLO V8 model and actually run inference on that in just a couple of lines of code. And both of the domain packages are fully rebased on Keras Core. So any code that you run in the domain packages can run on all 3 backends that Keras Core supports, with a couple of sort of caveats to mention. The main one is that pre-processing components in KerasCV and KerasNLP today are built with TF data. So if you're using, for example, data augmentation in KerasCV or tokenization in KerasNLP, those things will run inside of a TF data pipeline. However, one of the things that's really awesome about Keras Core is that you can run a TF data pipeline and feed that into a Torch or JAX model. So you can use all of our pre-processing regardless of what backend you're using, but you do have to use TF data for your data pipelining if you want to use those components. So here's a quick hello world of how you would use KerasCV. So you can see the first couple of lines are just setting this environment variable. You can do this in Python or just persistently in your bash environment. You can also do it using Keras's JSON config. But here we're just specifying what backend we want to use. And it's literally as simple as this. By specifying this backend, now we know that everything we do subsequently in Keras and KerasCV is going to run in JAX. So in these few lines of code, which I'll dig into a little later, we're loading up an image from Imgur. We are resizing it to the shape that we expect for a YOLO V8 model. We're loading up a pre-trained version of the YOLO V8, and then we're running predictions using that model. So here it's truly just a couple of lines of code, and this is actually running a YOLO V8 model in JAX with KerasCV and Keras Core. So to get into sort of the more technical stuff that I want to talk about today, I want to talk about building custom components in Keras. And historically, the way that that has been done is by writing an implementation of, for example, a layer using TensorFlow ops. But the Keras Core API offers this new API called KerasCore.ops, which is a set of the NumPy API and a set of all of the functions within it, which are implemented in Keras Core across all backends. So for example, if I want to say ops.arange, it behaves exactly like numpy.arange in TensorFlow, JAX, Torch, and of course NumPy. So if you want to write a custom Keras layer, you can do that by just using the ops API. And then when you drop this custom Keras Core layer into a Keras model, it will automatically work with all backends. And this is extremely flexible. This is how all of KerasCV and KerasNLP is written. And I think we have found that it's a really pleasant API to work with. However, one of the things that's really special about Keras Core is that you don't have to use our API. You are not tied to the internals of how our ops API works. And if you have a specific component or a specific framework or API that you really love for one of our specific backends that we support, you can actually pull that in directly into Keras Core. So on this next slide, we have the same layer that was defined in the previous slide, which is this token and position embedding, but it's actually implemented specifically in Torch, JAX, and TensorFlow. And what this is demonstrating is that, if you're a Torch user and you really love using the Torch API, you can build a Keras layer using pure Torch ops, and it will still behave like a Keras layer. And the same is true for JAX and TensorFlow. And in this case, you can see for token and position embedding, the APIs happen to be quite similar across the three. But in some situations, you might want to use some custom functionality that's only available in one backend. So to get into this a little more, I'm going to take us over to Colab, and we're going to walk through a code example of doing something just like this with Keras Core on a vision model using PyTorch. So here we are in Colab, and you can see I've got this instance running. I've done some pip installs, but the first thing that we do is we're going to specify our Keras backend. And in this case, we're going to use PyTorch. Then we're going to run some imports. And when you import KerasCV or Keras Core for the first time, you'll get a little print statement that says you're using the Torch backend. In this case, I've already run this runtime, so the import's already occurred, and we're not going to get that again. But from there, we've got Keras loaded. We've specified that we're using our Torch backend. And so everything from here on out is going to be running in PyTorch behind the Keras API. So here, we'll load up a file. We'll just load it from Imgur using Keras, and then we'll use the KerasCV resizing layer to resize it to the size that we want for a model. Here we're just specifying we're going to use YOLO V8 for object detection, and we're going to use a model that's pre-trained on the VOC dataset. So here we're just specifying what the names of the 20 classes are in the VOC dataset. And then here we get to jump into the KerasCV API. So here we can see in KerasCV as well as in KerasNLP under the models package, any model within models will have this from preset constructor. And you can load these string presets, which are available on Keras.io. And many of them are pre-trained, not all of them are pre-trained. And this allows you to skip a lot of the complex configuration steps or potentially pre-training or fine-tuning for a specific model or task. So in this case, we're going to load a pre-trained medium-sized YOLO V8 model that's been fine-tuned on the Pascal VOC object detection dataset. And in general, in object detection, we need to make sure we keep track of what bounding box format we're using. So we'll say that we want our detector to use this XY width height format, width height, excuse me. We can then just say model.predict. And regardless of what backend we've specified, this is going to go load the weights for this model and run inference on whichever backend we specify. And if you're familiar with implementing things in multiple backends, you might know that things like non-max suppression or even just the forward pass of your model can be very difficult to express in different backends, and porting that can be very challenging. But in this case, and in all cases with KerasCV and NLP, it's just one line of code. So this exact same code will run in JAX or Torch. And then we can see KerasCV will visualize this for us. And this is the same visualization we saw in our little quick start earlier, where the model has detected some potted plants as well as a dog. So now we're going to get into sort of the meat of the demo, which is how can we actually plug in some custom Torch component that we like into our vision model. And as we do this, I'm going to take advantage of the weights and biases API to use some of the niceties of its metric logging as we train our new model. You'll notice I'm using this weights and biases add-ons package right now. This is something that the weights and biases team is building to support Keras Core. And it's got some cool new features for training object detection and image classification models. So I'll go ahead and initialize my weights and biases run. And then we can jump right into using Torch. So if you've used Torch a lot, you're probably familiar with Torch Vision. Torch Vision has an awesome set of pre-trained models. And for this demo, we're going to go take one of these Torch Vision models and plug it into a Keras classifier. So in this case, we will just load torch models.resnet18. And this is fully in the Torch API. At this point, we are not using Keras at all. And we're just loading this pre-trained ResNet. And then we're going to strip off the the final layer of the model so that we're not getting the classification head for ImageNet. And we're just going to get the backbone leading into that classification head. Then we're going to move it over to the CUDA device, as one does in PyTorch, because we're going to train this model on our GPU here. And now we're going to move fully into Keras. So we have this backbone, which is just a torch.nn.module. This is not any fancy Keras construct. It's just a torch module. And we're going to drop it directly into a Keras model. So the way that we can do this is define a Keras model. And the only Keras component that it's going to need to have is this classification head, which in this case is going to be a dense head because we're looking at the cats and dogs data set for image classification. And then we can just define the call method of our model such that when we call our model, first, we're going to call this torch.nn.module on the inputs, which is, of course, our backbone. And then we're going to take the results and pass it through a classification head, which in this case is a Keras layer. And when we do this, the resulting cats and dogs classifier that we build is a fully Keras object that is no longer tied to the Torch API, but is part of the Keras API. And as a result, we can compile that model, specify a Keras loss, Keras optimizer, and Keras metrics. And so we've taken something that is fully Torch and fully Torch Vision, and we've plugged it in to Keras. And we feel that this is a really exciting feature, and we've seen a lot of really cool use cases of it already because it allows users to not strongly tie themselves to a specific backend or a specific framework because they can take pieces of whichever frameworks they love or whichever packages they're used to using and drop it right into Keras and Keras Core. Once we've done that, I've mentioned before that KerasCV and KerasNLP use TensorFlow data as the pre-processing utility of choice. And we're going to use that here. And what we're going to demonstrate here is that we can load up a TF data set and pass it seamlessly into a PyTorch backend Keras model and let it train. So I'm going to sort of skip over the details of this because what we're doing here is really just loading up a TF data set, and that's not the purpose of this talk. But effectively, at a really high level, we're loading this data set from TFDS, which is TensorFlow's datasets package. We're resizing it to the image size that we want for our classifier, and then we're just going to shuffle it for typical training efficacy reasons. And then once we've done that, we can use KerasCV to visualize some of our pictures. So this is cats v dogs classification. So you can see we've got a couple of cats and a dog. And then we're going to get ready to actually fit this model using PyTorch and Keras Core. So because we're using a Torch Vision backbone, we need to normalize our inputs to the structure that that Torch Vision backbone expects. So in this case, the ImageNet classifiers with Torch Vision are trained using images that are rescaled based on the mean and standard deviation of the pixels in ImageNet. And that's exactly what you see here is that mean and standard deviation. So we're normalizing what was previously 0 to 255 inputs using this scaling. And then critically, we're also going to transpose our images into channels first format, which is typical of PyTorch and is also how the Torch Vision models are trained. You do not have to use channels first format in PyTorch. However, the Torch Vision models use channels first. So if you want to use that backbone, you need to be consistent with that format throughout your model. So here we're defining that pre-processing. We're going to map our TensorFlow data set through that. And then we're going to go ahead and fit our model. So we can use the weights and biases metrics logger callback to keep track of this as it trains. And I've commented out here because it doesn't yet support channels first format, but I wanted to give a shout out to the weights and biases image classification callback because I use it quite a bit in testing and it's really quite nifty. So when you include this callback in your training, your weights and biases run on the weights and biases website will show example images from training as well as the classes that were assigned to them by the model during training time. And if you're familiar with training vision models, you know that it can often be very difficult to map sort of what the metrics are saying to how the model is performing from a human perspective, particularly in object detection, where you might see an average precision score, but what does that really mean from a human look? And so these callbacks for image classification and object detection are really nice because you can actually see, okay, here's the box that the model drew, or here's the class that the model assigned. So once we've done that, we can just call model.fit. And again, this is just the Keras API that we're used to. And you can see because this has a pre-trained backbone and cats v dogs is a pretty simple task, the accuracy goes up pretty quick. And after just one epoch, we will find that this model is above 90 or so % accuracy on the training set. And of course, once we've done this, we can actually go look at our run in weights and biases. And I'll pull it up real quick. And you can actually see we're getting the live results here in our weights and biases run, which of course is the lovely feature of weights and biases. We love using this to get notified on how our training jobs are going and all that good stuff. So back in Colab, you can see our model is continuing to train. And then once it's done training, we'll just call weights and biases.finish to close up our experiment. So that is the gist of the plugging in a PyTorch specific module into Keras Core for a vision model. And before I hand it over to Matt, I wanted to give you all a chance to chat about questions that are specific to KerasCV or the demo that I just did. We're excited about all your great questions about Keras Core, but to respect Matt's time, we're going to wait for Keras Core questions until the end. So if there are questions now about the PyTorch demo or KerasCV, I'm happy to cover them. And if not, we can hand it back over to Matt to talk about NLP. And let me see, it looks like we've got a little bit of a few questions. Let's see, most of these look like they are Keras Core generally. I will answer one that is a domain packages question. I see our domain package is going to support domains other than core CV or NLP, such as 3D data or geometric deep learning. There is currently not any projects in the work to expand the domain packages to these. We are trying to expand the offerings of CV and NLP for now, and if this continues to succeed, then we will look into that in the future. But as of today, there is not a plan to add 3D or geometric as extensions of the API. Today, CV does include some 3D modeling, but it's not the focus, as it's not what we view as the most impactful user base to be working with right now. Okay, awesome. With that, I think, Matt, I can hand it over to you to start talking about NLP.
Cool, thank you. So yeah, for second half of this talk, we're going to switch from computer vision to natural language. So natural language, basically, as opposed to programming languages, anything written or spoken, English, Spanish. And kind of as Ian's was a bit of like CV plus an exploration of what you can do on the Torch backend, my talk is going to be NLP plus a bit of an exploration of what you can do on the JAX backend. So yeah, to give a quick overview of the back half of this talk, like Ian did, I'm going to show a quick kind of hello world slide here that shows like a very simple training script for KerasNLP, just to kind of get everyone oriented in the library, what KerasNLP code looks like. And then we'll hop over to a Colab and do some live coding. And we will take a GPT-2 base model and do some really simple instruction fine-tuning on it on the JAX backend. So we'll talk a bit more about what instruction fine-tuning means as we do that. And then the last thing we're going to do for this half of the talk is we're going to basically recreate that exact same training setup, but at a much lower level by writing our own JAX train step and train loop, so we can kind of see what's happening under the hood there. And then that'll be it, and we can answer questions about any of the KerasCV, Keras Core, KerasNLP. Okay, so yeah, let's hop into Hello World with KerasNLP. So this should look quite actually symmetrical to the Hello World that Ian showed for KerasCV. The first thing you want to do if you're using the multi-backend version of any of Keras Core and KerasCV is you want to set your backend before you actually import the library. So the first thing we're doing here is we're setting our Keras backend to JAX, and that will actually affect how the library imports itself. So it's why you have to do it first. And then the overall goal with this training example here, it's kind of a classic NLP benchmark. We are trying to make a review predictor. So for I think it's 50,000 reviews from IMDb, we have labels of whether they were a positive or negative review. So we're going to load that up here with TensorFlow datasets. It's not actually important that it's TensorFlow datasets here. One of the great things about Keras Core is it's quite flexible in the data input formats you have, but I'm just showing this because it's a convenient one-liner. And then we're going to load our classifier from KerasNLP. And you'll notice here that similar to KerasCV, we have a models namespace. And in that models namespace, we have a bunch of classes with a from preset constructor. And that from preset constructor is going to be how you access all of your pre-trained weights. So we're loading up BERT, which is a model that's great at picking up just general patterns in text, great for classification problems, but not out of the box for any particular classification problem. And then we're going to go ahead and fine tune it on our IMDb reviews, which will turn our BERT model into a great movie review classifier. So we can predict 2 new unseen examples at the end of it. And again, this is just to get a high level sense of the library. We're not going to go deep into BERT kind of internals here or anything like that. But roughly for KerasNLP, this will be the flow you see. Usually you're loading a pre-trained model and doing either some fine tuning or inference or both with it. Okay, and with that, I will actually take over screen sharing and present a collab. And great, looks like we are on. So let me hop over to that window. So I actually went ahead and ran the first half of this collab already. And that's just so you didn't have to kind of sit around watching me download pip packages and everything. But to go over the setup we've done here, I've just installed KerasNLP. I've installed weights and biases. I also installed that Somik in this call wrote a weights and biases add-on, and that's particularly for this multi-backend Keras we're talking about. It gets you the callbacks that work with multi-backend Keras today. We've logged in, and I've set the backend to JAX like we just talked about. The other thing I included here, and this is really for after the call, if anyone is interested in the quick start, I just recreated it here verbatim for reference. But this is just if you wanted to play around with the quick start after the call, but we can hop over that to the instruction fine tuning part of this talk. So before we dive into this, it's probably good to talk about what actually is instruction fine tuning. So when we're talking about instruction fine tuning, we're usually going to be talking about generative language models. So these are models that essentially are just really good at predicting the next word based on all the words that have come before it. So we're going to be using GPT-2 here. That this training setup also applies to Llama or ChatGPT or Bard. But essentially the way that you're training these kind of base generative models is you are playing this kind of predict the next word game at this massive scale on a huge amount of text from the internet. So you're just taking a ton of examples of natural language and loading them all up and training your model by progressively feeding it sequences and asking it to predict the next word based on everything that came before it. That gets you this base model that has all these super interesting emergent properties. But the issue with these base models is that you kind of get what you pay for. They tend to just take a direction and ramble off on it, and basically are just trying to parrot what sounds like might be text that came from somewhere on the internet, which is exactly what you trained them on, which is generally not that useful. If you think of something like ChatGPT or Bard, what can be a lot more useful is something that's attempting to have a kind of question answer flow to it. So given some instructions, try to give a response that's helpful based on those instructions. So that's the idea behind instruction fine tuning. You're kind of trying to just steer this model that's been trained sometimes on, I think the big ones these days are on trillions of words on the internet, trillions of tokens. And you're just kind of steering it without trying to teach it really any new facts or anything. You're just trying to steer it in the direction of being a helpful question answering thing. And there's a bunch of different ways to do instruction fine tuning. Some of them are quite complex and very expensive, involving reinforcement learning and a bunch of human annotators. We're going to do the really simple version here because it fits well in our talk, which is just supervised instruction fine tuning. So to show what that means, let's go ahead and load up our data set here. And this is a data set from Databricks of kind of questions and answers. And what I've done here is some of these, actually, let's go ahead and take a look at the output so we can see it. We're just going to be taking this data set of JSON and giving it a specific format of an instruction and response. And the only things I've done here that are non-trivial are some of these examples have some additional context. It would be great to use that, but to keep our code really simple here, I've just thrown all of those out. And the other thing I've done is I've chopped our data down to just 1,000 training examples. That is purely for speed in this talk. It would be better to use more examples. I just want to keep this talk moving quickly. So yeah, you can see that we've kind of formed these examples of kind of strings with a question and a response, and it's all just in one big long sequence. So the way that we're going to do our instruction fine-tuning is the exact same way that GPT-2 or other models are trained in the first place, which is just play that guess the next word game throughout training. But instead of doing that guess the next word game on random documents on the internet, you're doing it on question answer pairs, and that kind of steers the model towards being a question answering model. So with that, we can get into actually loading up GPT-2. So yeah, again, we have our models namespace, we have our from preset constructor. Yeah, you can see we're 300 million parameters, which I think is a few orders of magnitude larger than what Ian was showing earlier in this talk, but is actually on the large language model side of things is very small. Usually when you're talking about large language models these days, you're talking about billions of parameters. I'm just using a small model because this is a short talk and I want to be able to show training quickly, but we'll actually see that affect performance later on. The other thing I'm showing here, without getting too much into detail, is that you can pass your optimizers, pass metrics, pass losses. KerasNLP and KerasCV are extensions of the Keras API, but they allow you to use the same constructs that you're used to with core Keras. So with our model loaded up and our data set loaded up, we can go ahead and set up our weights and biases metrics and go ahead and fit our model. So one thing worth talking about here, as we kind of let this spinner run for a while, is the first kind of time to see the first train step show up is going to be really big. And this is true on both the JAX and the TensorFlow backends. And the reason for this is compilation. Essentially what's happening here under the hood, and we'll see this in more detail later on, is JAX is taking this description of all the linear algebra in your forward and backwards passes and optimizing it as much as you can with a library called XLA, Accelerated Linear Algebra, and gets you this super fast version of your train step that doesn't actually, you don't actually need to like re-execute all of your Python code for your train step every time you're running your train step. So you're essentially paying this big down payment for compilation here, which will be slow, but then the benefit is after you've done that and you're on training your model, and I think soon we should start to see some train steps pop up here. You'll see it, I think we'll hit like, yeah, what are we? Roughly three or four train steps a second now that we've actually finished our compilation. So yeah, we are up and running with our training. So I can actually go ahead and hop over to when I logged into weights and biases, our run, and take a look at the metrics. So yeah, I think Ian already showed all of this. The only thing kind of worth calling out here is one thing, as we compiled our model, we tracked just a really simple accuracy metric. And you're able to see that as our training progresses, we are able to get to essentially a 50% accuracy on this guess the next word game. So half the time the model is able to predict correctly the next word in the sequence, which is decent. So yeah, I'll let that run, but we can kind of cover the next bit of code as it's going. So after that finishes up, we're going to actually draw samples from our fine-tuned model. That's what this generate call will give you. So generate, this is something that's not part of core Keras, but is actually a kind of new top-level API that we're giving as part of KerasNLP for language models. And all generate is going to be doing is running your prediction for the next word in a loop. So you'll just get GPT to predict one word and then the next word and then the next word. and that will create an entire generated sequence of text in response. So we'll go ahead and run that on these 3 examples, and we'll see how well we do here. One thing I will note is, because this is a small model, this is 300 million parameters and not like, I think 7 billion parameters is a quote unquote small model release for like the Llama 2. So you'll definitely notice performance we'll probably see this attempt to answer a question, but I expect to see kind of a lot of somewhat hallucinatory results as we go ahead and do this. But yeah, I think we should be wrapping up training soon, so we can see how it does with our 3 questions here. And the other thing you'll notice, again, with generate, so this is going to be, we're running prediction in a loop, but it's actually a compiled loop. So the entire process of running a forward pass, generating a probability distribution for your next word, then we sample from that distribution, and we do that in a loop up to the sequence length that we want to generate. And we will actually compile that thing with JAX. So similar to we saw for fit, the first time we call generate is going to be very slow, and the second 2 times, once this one finishes executing, should be very fast. And yeah, the other thing I can note here, as we're waiting for this to finish up, is one thing you can do to kind of customize the way that you sample things, so here things come through, is during compilation, you can pass a sampler as well, which will control kind of the way that you're sampling your distribution. So if you want to do greedy sampling, which would be kind of a very tight read of your just the most probable word in a distribution, or random sampling or top case sampling, you can do that by passing it to our compile. Okay, and here we've got our responses. So machine learning is the use of data to learn new things about the world. You can definitely see that we've kind of steered our model in the direction of being a question answering thing. If you want to travel around Europe, you should plan to visit a lot of cities, and cities should be the first thing you do. Not super helpful. And then how many bowling balls fit in the car? I've just included this for fun. I've never seen a model of this size do well on this, and indeed, it's just talking about a description of a car here. So yeah, feel free to play around with this afterwards if you're interested. You'll definitely get very different responses if you kind of rerun these a few times. But with that, let's go on to the last kind of section of the talk here, where we're going to peel back a layer and kind of recreate that exact training setup, but with lower level JAX primitives. We're going to write our own train step, and then we are going to write our own entire training loop. And one reason to do this is just because it's, where this is a talk about multi-backend Keras, it's genuinely useful to just kind of understand what happens when you call model.fit. There's a lot going on under the hood, and it's nice to know what that actually is. But there are some other reasons you might want to run a custom train loop in production. Some of them would be like a more kind of complicated training setup. Like a GAN would be a time that you might want to write your own custom training loop. But very relevant for JAX is JAX has some really efficient and scalable distribution APIs for kind of training a model across an entire fleet of GPUs or TPUs. So one thing you could use writing a lower level custom training loop in JAX is really get kind of access to these distribution APIs in JAX at a really low level and optimize your train step in JAX if you wanted to. So yeah, with that segue, let's go ahead and load up our model again. And this time I'm going to show loading our model with the pre-processing split out. So as Ian was talking about with KerasCV, both of our libraries are running all of our pre-processing with TF data. And we won't get too deep into this in this talk, but the things to note are TF data isn't actually going to restrict you from what backend you want to be using for training. We're using TF data with JAX here, and you could be using TF data on the Torch backend or the TensorFlow backend. And TF data is a very efficient and scalable API for running preprocessing, which is why we are built on top of it. So yeah, here I'm kind of showing this preprocessor when it's attached to the model was running kind of implicitly in fit, but it was really running everything that's being shown here, which is making a TF data set of your data and then mapping your preprocessor over your data set. And if we run this here, we can see that that will take our kind of long strings of input, this instruction response input, and turn it into a sequence of token IDs that we can pass to a model. And the other thing I will do here is create our optimizer and loss. This is the same optimizer and loss that I created earlier in the collab. We're just splitting it up so we can use it again. And then here we'll kind of land at like the actual JAX bits of our custom train loop. So yeah, there's a lot of kind of code here, but you really need to only understand one real principle to understand like kind of why the JAX code looks the way it does, which is that JAX is all about pure function transforms. Basically, JAX really, really hates side effects. So if you're used to Torch and TensorFlow, you might be used to variables that you can just kind of, they're stateful things. And whenever you want to kind of poke new data into a variable, you absolutely can, and you just assign a new value to a variable and you're off and running. JAX has a different approach where it wants to kind of know about every time you're writing a function, you have to pass all of the variables that you care about in and all of the updated variables that you care about out. And some of this is stylistic. Functional style of programming is something some programmers prefer. Another reason for this is performance. Because JAX can know that you have these nice stateless functions, it can really do a lot more in terms of optimizing what you write. So here we're going to define a loss function, but unlike a loss function where you're just using a stateless model, we pass all of our variables in along with our batch. And then as we compute our loss, we need to use one thing that Keras Core provides is a stateless version of kind of most of the kind of top level methods that you're used to, basically so that you can write things like this in JAX. So here we're going to use a stateless call, which is the same as a normal model.call, except it allows you to pass your variables in and get your updated variables out. So with that, we've created this stateless function for computing our loss, and we can pass it to a JAX function transform, which is something that takes in a function and spits a function out. Here, JAX value in grad takes in this nice stateless loss function and gives you a function that computes the loss, but also computes gradients for that loss. And with that, we can actually define our train step, which is going to take in all of our state again, trainable variables, non-trainable variables. And here we actually have to care about optimizer variables because we're going to be using an optimizer to update all of our JAX variables here. We'll use that gradient function we just defined to actually compute gradients for our loss. And then optimizer, much like our model has a stateless call with Keras Core, in Keras Core, an optimizer has a stateless apply, which is something that allows you to apply gradients to your variables by passing all your variables in and getting updated variables out. So we're able to write this where we're computing our loss, updating all our variables, and it is completely stateless. And now that we have that stateless no side effect function, we can run a jax.jit function transform on it. And this is the compilation we were talking about earlier. That compilation that was making the first batch of our fit call slow, it really, if you look in at the Keras Core code, we are just calling jax.jit to run XLA compilation on our training step. So we can go ahead and run this, and then we are basically all done here. The last thing we need to do is create our optimizer variables. So we have all of our state ready to pass to our pure function train step. And then you can see we just kind of go batch by batch over our data, pass all of our state and our batch in, and we'll just get an updated version of our state each time as we go. And again, because we've wrapped things in this jax.jit call, you'll kind of see us have to pause for a while here as we let the first train step compile. And then after we've done that initial compilation, you'll be off and running, and we'll be running, more 2 or 3 train steps every second or something like that. So yeah, that's, I think, all to show. And here we go on our training. writing a JAX custom train loop. And again, what this does is you can really use any of the low-level JAX APIs that you want in your training. In particular, JAX distribution APIs. So if you're interested in going deeper, I've included some extra links here for distributed training with JAX, as well as the getting started guide for KerasNLP. Yeah, so at this point, I will stop screen sharing and open it up for questions. But yeah, I think overall we're very excited about multi-backend Keras, particularly for pre-trained models like this. It is super useful to be able to kind of write your numerics once, have all your weights once, and kind of mix and match between different backends. You could even do something like fine tune in JAX and deploy on TensorFlow. So we think it's a kind of interesting new tool that wasn't in ML developers' tool belts before, and we're excited for it with Keras 3. Thank you.
I hope it clears the war over frameworks. Now we have a framework that we all can love and enjoy writing ML code on. Yeah, let's get into the Q&A section. Feel free to drop in questions. We are taking up questions as well. We have enough time. Yeah, I mean, let me get started then. Matt, I have a question for you, because we took one question KerasCV specific kinda. So let's start with the KerasNLP specific. So it's like obviously most of the developments, LLM developments, are done in PyTorch, specifically PyTorch, and I believe that there's a difference in the technical aspects that we have to cover in order to start fine-tuning or doing inference on large 7B or 70B billion models. But it was just curious, what are the large language models in the billion scale that KerasNLP supports out of the box right now? And given we can use a PyTorch backbone with Keras Core and KerasNLP in this case, can we use like a PyTorch GPT model instead of a KerasNLP GPT model?
Yeah, you definitely should be able to use, as Ian was showing, like if you want to use a model written in PyTorch and wrap it in kind of Keras training APIs, you can definitely do so. One trick though to call out with NLP in particular is if you are using a pre-trained weights from somewhere, you need to make sure your tokenization is exactly one-to-one with wherever tokenization has been used somewhere else. You can't, the inputs to the model need to be exact, or you're not going to get any good results. But you could use KerasNLP, to get the kind of the exact same tokenization that you would get for a model, and then load up a torch-only version of a model if you wanted to.
Nice.
Yeah, and then in terms of models that we have GPT-2, OPT, T5 is on the way, some sequence-to-sequence models, and then we're actually hoping very soon to bring a lot of kind of these bigger language models, such as Falcon, like nice permissively licensed large language models. Then we should have those available soon.
Yeah, that's so cool. Just a quick follow-up, and then I can let it. Yeah, then maybe Somi can ask a couple of questions. The follow-up is, like, say if we are using a PyTorch PT model, language model, can we, and you showed the generate method, can we kind of like write our own generate method and override the existing generate method?
Yes. So yeah, the overall generation is, I think, compared to the like super very simple setup that you get when you're like training a causal language model, generation is a fair bit more complex because you have to deal with, especially if you want a performant generation like in JAX, you do need to make sure your while loop is compiled. You want to make sure you're caching all these kind of intermediate states, the kind of key value tensors that you compute in your transformer. So it's certainly like writing kind of custom generation code is a decent step up in difficulty just in the subject matter, I think, but it's definitely something that we support. If you want to be writing your own generation step, you can kind of see the generation step that we provide and customize it. And it is a place that we want to support people doing that. The other thing we do, which is a little easier to do, is you can pass your own samplers. So if you want to use like different sampling methods like top K or contrastive search has been shown to be very effective in recent years, you can do that in a much easier way by just passing like a sampler equals contrastive to our compile and be up and running with that.
Nice. Samit, do you want to take questions from the chat? This will be a nice one.
Yes, I think there's this question. So how do you compare the runtime for different backends with Keras Core?
When you say runtimes, do you mean the like literal wall clock times, or do you mean the runtime in the like programming sense of a runtime?
Probably in the programming sense. I'm not sure this came from the chat.
Okay. Well, there's sort of
Wall clock time.
Okay. Yeah. I'll touch on both briefly. It's pretty easy to compare the numerics because we have a bunch of models where we reload the weights in all of our different backends, and we run tests that verify that the output of those models are the same across backends. And then from models all the way down to like individual layers, components, etc. For like wall clock time, like how fast are these things? It's pretty easy because the configuration is just such that you specify your backend as an environment variable. So we can spin up two identical GCP instances that have the exact same resources and have them both have different environment variables for backend and run the exact same Keras training or evaluation job and just time them. It's actually quite straightforward.
Yeah, so we've been doing a lot of kind of benchmarking for Keras Core, and it's actually super fun because Keras Core kind of lowers the barrier between switching between frameworks. It's really interesting to see like Torch has a lot of kind of very optimized ops specifically for computer vision, and we're able to kind of see how performant those are. On like the NLP side, I know that JAX is actually, because of kind of all of these nice functional assumptions it makes, it can really optimize training really well. And we've actually seen it perform like a hair better than any of the other frameworks in actual running fit. And then on the inference side, I think TensorFlow, like on the generation side for inference, has actually been a little bit faster. So it's kind of fun to be able to just flip the switch between backends and be able to check what performance is for a given model.
Nice. Thanks for answering that. Another question from the chat is around distributed training. So the question is, how will Keras Core handle distributed training with different backends, and specifically model parallelism and not just data parallelism?
Yeah.
Sure. Yeah, you want to go ahead?
Yeah, we are. So today we'll work, like I was saying, if you want to write your own custom train step in JAX, you can use any of the JAX APIs for doing model parallelism. Same with Torch and TensorFlow. If you kind of go specific on a backend, you can use the distribution APIs that exist today. In TensorFlow, we have the TF distribute API, and you can just make a Keras Core model, run it inside of a TF distribute scope, and things will just work. But it's an interesting question you asked because we are actually actively developing a API that will be a nice cross-platform API for model parallelism that will just work as you switch backends between JAX and Torch and TensorFlow, and we're super excited about that. So stay tuned for more details there.
No, you can see some of the development of that. There's a little RFC PR that you can find on Keras Core because we're all open source. You can look at it. And Scott, who's a real rock star on the Keras team, has been building out this API, and it's quite impressive. We're really excited to share it with users. He was able to train a large language model using model parallelism with like a dozen lines of code. And I think Francois will definitely be sharing that on socials as well when it's officially released, which hopefully is it will definitely be before the Keras Core 1.0 release. But you can expect to see it in the coming weeks, I would say.
I have a quick question from my end. So for parallelism on the PyTorch side, so is there any plan to integrate with some tools, for example, Hugging Face Accelerate to support that kind of parallelism out of the box using Keras Core?
So yes, PyTorch is something that our team has a little bit less expertise in, and so the time horizon is going to be a little longer on that. But we do intend to support PyTorch behind our distribution API, and that also includes compilation. We're still scoping exactly how that's going to work.
But I actually do know there's an issue specifically on Keras Core for PyTorch Accelerate, where I think someone has already gone ahead and checked that you. Wait, Somik, were you actually on that issue you made? That
I actually asked Anshuman to make the issue.
Oh, nice. So yeah, I do think you can run PyTorch Accelerate with Keras Core models on the PyTorch backend. But yeah, I think overall for us, the distribution that we're really excited about is distribution code you can write once, write simply, and take across backends.
Thanks for the answer.
Thanks there. I have a very nice question, and I guess this is gonna be a good question for most of the folks in the audience. So someone asked that coming from PyTorch, are there any suggestions for the best fast track way of learning Keras?
I think that's a great question. We don't have a lot of resources yet on how to, for example, port a PyTorch thing to Keras Core. You'll find that generally the ops namespace in Keras Core is quite closely tied to the Torch API, with a handful of small exceptions. I would personally strongly recommend Francois' book on Keras. It's called Deep Learning with Keras. I'm not just saying that because he's my boss. Like, it's actually a really great resource. It's how I learned about deep learning. And
deep
of course,
learning with Python, I think.
Oh, sorry. What did I call it?
Deep learning with Keras.
Oh, sorry. Deep learning with Python. Excuse me. Don't tell him I said that. As well as Keras.io. Keras.io has some really cool examples. There's literally hundreds of examples of how to do this thing in Keras, how to do that thing in Keras. And it serves as a really good piece of API documentation, but also of a how-to. That would be my recommendation. Not sure, Matt, if you have a different take on that.
No, I totally agree. If you go to Keras.io and you're actually specifically interested in the multi-backend stuff, there you'll notice there's a spot there, Keras Core. So yeah, just to make sure all the terminology clear, Keras Core is what will become eventually Keras 3 in the new stable version of Keras. But right now it's got its own little breakdown section on Keras.io, and you can read all of our kind of basic developer guides written from a multi-backend perspective there. So that would be a great place to start for this stuff we've been covering in this talk.
Awesome, Matt. Sorry. Yeah, thanks, Matt and Ian, for that answer. I hope that helped. We only have 1 minute. I just want to take this time to say that I'm not sure if we were, myself and Somik, we were able to transfer this energy that we're very excited to have you over for this webinar, because we have been using Keras for a long time, and we really are excited that Keras Core is out there, and yeah, we can literally use all the goodness of PyTorch, JAX, and TensorFlow with the same abstraction there. Right? It's just great, and I highly recommend folks to try it out, play with it, try to implement the next deep learning project with Keras Core. That will be really fun. Plus, yeah, just excited to try it myself as well. Like, I've been trying it, but try it more. And I would also like to share with the participants here that we are actively maintaining weights and biases integration with Keras ecosystem. We have nice callbacks that you can use, and that will start doing model checkpointing and experiment tracking, and you can even customize our evaluation callbacks to build your own stuff. With the Keras Core, we are going to be updating the current existing callbacks that we have so that it supports all the functionality out of the box for Keras Core. So stay tuned there as well. And yeah, just if you have questions, write to us, tweet about it, or yeah, just open an issue in either any of the Keras ecosystems library, and yeah, they will take it from there. Matt, Ian, Sumit, wanna say the ending lines?
Yeah, I just wanted to say thanks so much for having us. This was fun. And I love using weights and biases, and the Keras integration support makes things super easy. So yeah, thanks for bringing us on.
And we love using Keras.
Yeah, thank you all for everything you've done for the community and for having us here today. It's always a pleasure to get to share what we've been working on, and we're really excited about weights and biases and Keras moving forward.
Awesome. Yeah, we are already about over the time, so we will be closing in. Thank you all for joining. Yeah, we really appreciate the patience, and I hope you all learned something and do try out Keras. See you all.